Hello, welcome back to BECE Mastery, where real-life lessons meet exam excellence. Remember, in this video, all we are doing is help you solve past questions in as much as BECE is concerned. In this very video, we are looking at BECE 2024 Paper 2, question number 6. And question number 6 happened to be the last question for Paper 2. And the question says that copy and complete the table for the relation F is equal to 9 divided by 5 C plus 32, where F and C are in degrees. So F is Fahrenheit and then C is degrees Celsius respectively. And so the table has been given unto us. We have degree Celsius and degree Fahrenheit. Now they've given us all the values for degree, which is from 0 through 5, 10, 15, 20, 25, and 30. And then they've given you some few values for the Fahrenheit, 32 and 68. Now we are to use a scale of 2 centimeters to 10 units on the vertical axis and 2 to 5 units on the horizontal axis. And then we are to draw a linear graph for the relation. And we are to use our graph to find the temperature in degrees Celsius when Fahrenheit is 55 degrees. Then again, we have to interpret the slope of the relation. So this is the question that we have here. And so what we have to do first is to create a table or to complete the table. And the table, the relation is that for every degree Celsius, I can multiply 9 feet plus 32 to give us the answer for the Fahrenheit. And so when I substitute 5 into this, realize that I'm going to have 9 over 5 times 5 again plus 32. Okay, so when I cancel 5 by 5, I have 9 plus 32, and that's going to give me 41. So I can put 41 here. Again, if I use 10, I'm going to get 9 over 5 times 10 plus 32. Again, 5 can divide itself, and 5 can divide 10 as 2. And so I get 2 times 9, which is 18 plus 32, and that will give me 50. Okay, so I'm doing this through. And then again, when I have Fahrenheit to be equal to 9 over 5 times, now my C is 15. So if I say times 15 plus 32, 5 can divide itself 1, divide here as 3. 3 times 9, 27 plus 32 will give me 59. So I do the same thing for 25, and that would be 77, and 30, and that will give me 86. So these are the completed table of values to be plotted. And so all I need is to get my graph paper, of course, or my graph paper can be like this, and I have to use the scale. According to the question, I should use the scale of 2 centimeters to 10 units on the vertical axis, that is the y-axis, and then 2 centimeters to 5 units on the horizontal axis, which is the x-axis. And we are using F as horizontal, vertical, and C as horizontal. Right. So again, and remember that we don't have negative here, so we can shift our line down the y-axis so that we don't create more negative values. And I can do the same thing for x, shifting it to the more negative side so that I can create more space for the positive values of x. Okay, so according to the scale, I have to use 2 centimeters to 5 units on the x-axis, which I have all these values, and then again use 2 centimeters to 10 units on the y-axis. So I have this coming on board beautifully, and then my origin is 0. Okay, so I'm going to plot the point one after the other. Okay, and so according to the first point, when x is 0, when C is 0, so this is my C in degrees Fahrenheit, and this is my F, which should be labeled nicely. This is my F in degree Fahrenheit and C in degrees Celsius. Sorry for that. Okay, so if I have 0 for C, then F is 32, so I can plot that over here, 32. This may not be accurate because this is the computer work and I may not get it so well as it's supposed to be, but I'm sure with your graph you can plot it exact as it should be. Then when S is 5 or when C is 5, F is 41, and that can be here. So I do 10 and 50 as well. I do 15 and 59. I do 25 against 68. Then 20 against 68 and 25 against 77, and finally 30 to 68. Then with my straight edge, I will draw my straight line to pass through this, and so that becomes my linear graph. And I'm sure you can do this easily, right? Good. Now the question that follows says that I should use my graph to find the temperature in degrees Celsius when Fahrenheit is 55 degrees. So all I need to do is to use my graph, not to calculate it. And so I will read the value of 55 on the F direction, and 55 will be somewhere here, right? And so I will draw a horizontal line straight to meet the line on my graph, or my straight line, and track it down to the x-axis, which is the c-axis. And here the reading is going to be for every small line will represent 0.5, or I can say for every 2 lines will represent 1. That is the scale that I have here, and so this will give me 12.5. okay, but I don't know, it may not be the same as yours if you use the graph itself. When I use my graph on paper, I had 12.75, but this one is giving me 12.5. Fine, whatever probably the case, that is okay. I'm sure you can get a good reading. The most important thing is that you know how it's being done. Okay, so that is that, just that, and you are done with your question. Then the next question says that interpret the results or your relations. Now to interpret it, interpret the slope of the relation, the slope of the relation, which means you are to find a gradient. Okay, so I'll pick 2 values, maybe from y-axis and 2 from s-axis, any 2 at all, to work it out. And we know that gradient is always equals to change in y, and so if I choose 50 minus 32 over the corresponding x value 10, also minus 0. I prefer the 0 because it makes the work easier for me. When I subtract this, I have 18, and I subtract this, I have 10, which is equivalent to dividing both sides by 2. I have 9 over 5. So this is my gradient, which is more or less saying 1.8. okay, and so how do I interpret this? So the interpretation simply means that to every unit of degree Celsius, I have to increase to every unit of degree Celsius, I should get 1.8 degree Fahrenheit. Or I can also say that for every 5 degrees Celsius, okay, 5 degrees Celsius is equivalent to 9 degree Fahrenheit. That is what it also means, I mean, to interpret it this way. And so I'm sure this is quite good, and it has really helped you to understand or review your knowledge on linear graph. Thanks so much for watching.